Okay, we got a little review for Q-1-7. Q-1-7 is all about vector addition. It's basically got two parts. We got the graphing part and then the math part. And you'll need a ruler for this. Take your measurements in the first part. So we're going to use this scale right here. 1/4 inch is a foot. And hopefully you know what a 1/4 inch is. 4 quarters in 1 inch. So 1 inch would be 1 mile. 2 inches would be 8 miles. 1 3/4 would be 7. We're also going to need a protractor to be able to take these measurements. So with your protractor and your ruler, you can kind of go through and walk the course that the ant is making. We head north for 7 feet. So if this is my start right here, this dot, I want to take it up 1 3/4, just like this. I like to label my vectors as I go, so later when I go down to my component chart I don't have to search for them. The ant then turns south of east for 10 feet. So I want to turn my protractor so it's east, the flat part is at least, and I want to go south of east for 25 degrees. So here's 25 right here. South of east, 10 feet, that would be 10 quarters, which is 2.5 inches. Then it goes south for 5 feet. I'm going to turn and go due south for 5, that's 1 1/4. So I come down here, 1 would be a mile. I keep on going for another quarter, 1 1/4 or 5. And then it exits 25 degrees, turns east for 5 and then exits. Okay. Turns east for 5. Go 1 more is 5. Turns east for 5 and then exits. So we went north for 7, then he turns south of east for 10. Then he goes south for 5, and then he turns east for 5 and exits. What we want to do is calculate the resultant now. So the resultant is from the origin to the end point, the origin being the anthill, the end point being somewhere over here. So this is my R, or my resultant. I should have dotted that. Too late now. So we have our resultant, and we can now measure it. So when I take my measurement, I'm seeing about 3 3/4 inches. So 3 3/4 inches is how many feet is the question. So we have to use our scale in reverse. We know every 1/4 inch is a foot. Therefore we would have 12 feet and 3 inches, and then we just have to add 3 more on there, and that would take me up to 15. So we're saying that the resultant is equal to 15 feet. So we measure and then we turn it back into feet. We also need to measure the angle. So doing that, we can use a protractor. I'll just turn my protractor like this and take my measurement. Looks like I'm sitting about 10 or 11 degrees. So I'll just say 11 degrees south of east. Remember, we have to get within a 10% air threshold here, and hopefully I will do that when we get all done here, and we'll see how close I was. Some of these are real easy because they're due. For example, when we went due north, that was simply +7 and 0 for the x. Vector 2 is the hard one, we'll come back to that. Vector 3, we went -5 in the y and 0x. And then vector 4, we went to the right 5, so x is positive and y is 0. So now let's try to recreate this triangle and solve for this part right here. So we went at some x component, and it looks like it's bigger than the y component. So we have an x and a y. I know that because it was a 25-degree angle. So since this is 25, that's going to make the x bigger than the y. And then I also have to put in my hypotenuse. My hypotenuse was 10. So some of that 10 will be x, some of that 10 will be y. Here's my y, here's my x. Wherever the angle touches is cosine, so I can say cosine 25 degrees is equal to adjacent, which is x, over the hypotenuse 10. Another way to write that would be 10 cosine 25 degrees. That makes the other one sine, so I can say 10 sine 25. So x equals this, and y equals this. Wherever the angle touches is cosine, and the other one has to be sine. And we always follow this general format when we're breaking down these vectors of hypotenuse, function, angle. So hypotenuse, function, angle, hypotenuse, function, angle. We just use different things to do that. So we say 10 cos. You might want to check to make sure in degree, which I am. 10 cos 25. 9.06 will be the x to the right. That makes the y equal to 10 sine 25, or 4.23. And we're going down, so it's negative. Now I can check myself with the vector calculator, and I recommend doing that if you have vector calculator. So vector calculator number 4, and what I want to do is I want to put in my r and my theta. I'll change my r to, it's not letting me change, I'll change it to 10, and I'll change my angle, and this is where it gets a little tricky. It'd be negative 25. It's going below the x-axis by 25. I hit enter, and it reflects my vector 25 south of east, and all I gotta hit is view, and I can find my x and my y. My x is 9.06, my y is negative 4.22, and that's exactly kind of what I had here. So we now need to find our totals. So what we want to do is add up all our x's and y's. So I say 9.06 plus 5, I get 1406 in the x, so I moved in the x 1406 away. And the y, I'm going up first, 7, but then I turn around and I have to add a negative 4.23 and then a negative 5. So I get negative 2.23 as my endpoint. So that's really what we're doing here, is we started here at the start and we ended up, oops, that's not true. We started here at the start, 0, 0, and we ended up at an endpoint of 1406 and negative 2.23. So that's how far in the x we moved and how far in the y we moved. So what can we do with those? Well, what we can do with those things is we can take these endpoints and make a new triangle, and we can find out what the resultant was using math. So once again, we went over in the x 14, and then we went down 2. So I have 1406 here for my x and negative 2.23 here for my y. And then what we want to know is r, which is going to be the biggest side of the triangle, and we also want to know this, the angle theta. So if I take 14.06 and I square it and I add it to 2. Notice I dropped the negative sign, just the magnitude, not the direction, is important. I'm going to go through here and do Pythagorean theorem and solve. 14.06 squared plus 2.33 squared, and I square root all that. Didn't like that. I get 14.25 for my resultant. And I believe with our graph answer we measured it as 15. When I write that down, yeah, 15. So that's definitely within the level of 10% error. And then to find the angle, I can do inverse tan. So we know that tan of theta is equal to the opposite over the adjacent. In this situation, the opposite is y and the adjacent is x. So another way to say that would be 2.23. Notice I dropped my negative. Divided by 1406 is equal to tan theta. So to get theta by itself, I have to divide by tan or take inverse tan. So theta would be equal to second tan, or tan negative 1, inverse tan, divided by 2.23 divided by 14.06. So I get an angle of 9.01. So I would say theta is equal to 9.01 degrees south of east. Last time I think I had a angle measurement of 11. It's just probably my awesome paper protractor coming into play. So if we now know that the correct answer is 14.25, and what we got when we did our graph was, let's see, 15. So actual minus theoretical divided by theoretical times 100 if we want to calculate our percent error. for this one, and this is kind of how I grade your graph, because I'll know what the right answer is, and I can just do this quick subtraction and division. I had 5.26% error, so you know I'm getting full credit on my graph. I ended up in the right quadrant, and my resultant wasn't too far off. Those are the requirements for full credit. So just to recap, we got graphing. We go through, we walk the path, we figure out exactly what the resultant is based on our scale. We use a protractor to measure the angle. They're not going to be exact. They're going to be a certain amount of error for measurement. Then we come down here and we do the component method. So we break each vector down into its x and y parts. We get the totals. From the totals, we create a new triangle. Based on the new triangle, we can then use Pythagorean theorem and then inverse tan to find the resultant in the angle, and it's exact. And then I went through and I calculated my percent error. Not that you have to do that. That's just something I'll do for you to find your grade. Okay, study hard. Remember, Q-1-7. See ya.